So this video will go over section 5.2 on balancing chemical equations. So how to balance a chemical equation? This is a procedure here. So the first step is to write an equation using the correct formulas for the reactant and the product. And we call this the skeletal equation. Step 2, you need to count the atoms of each element in the reactant side and on the product side. Step 3, you need to use coefficients to balance each element that is not already balanced. And then finally, when you're done, you want to check that the final equation is balanced because that's the goal. You want it to be balanced. So let's try with first simple examples. And we will go through the balancing of the combustion of magnesium, the reaction of magnesium combustion. So if the text of the problem was like this, when magnesium metal burns in air, it produces a white powdery compound called magnesium oxide. And you have a picture here showing a ribbon of magnesium being burned, and it produces a very, very bright light, intense. And so what's left after that is just white ashes that are magnesium oxide. So you want to write the skeletal equation as your first step, which means writing the formulas of the reactant and the product and have correct formula. If you have not written your reactant and product formulas correctly, it will be a struggle to try to balance, and even impossible. So it's an important step to start with proper formulas. So when you have metals, a metal like magnesium is made of just atoms of magnesium. And so the symbol we use for that is just the symbol for magnesium. And then we can say in parentheses S for solid. Whenever something burns, it burns using the oxygen from the air. So whenever you are doing a combustion reaction, you will need to add oxygen, and that's the diatomic molecule O2, and it's found as a gas in the air. So O2 with a G in parentheses for gas. So on the left side, we have magnesium solid plus oxygen, O2, a gas. And if you start the reaction with a flame, it goes and you produce magnesium oxide. So how did we get MgO? Magnesium is an alkaline earth metal from group 2A, so with 2 positive charges, right? The group number tells you the charge, and it's a metal, so it's positive. Oxygen, non-metal from group 6A, is making the oxide ion O negative 2. Why O negative 2? Because oxygen being in group 6A, you do 6 minus 8, it's negative 2. Non-metals make negative ions. And so you can see that the 2 plus can cancel the 2 minus, from magnesium to oxygen. And so only one of each ion is necessary to make a neutral formula. So that's why the formula is just MgO. And we were told it's a white powdery compound. It's a powder. Powder is a solid. So S for solid in parentheses after MgO. So the next step is to count the number of atoms on each side. So let's start with magnesium. We have one magnesium on the left, one magnesium on the right. And so you want to write that under the equation and have the number on the left side and a number on the right side, and indicate what you're counting in the middle under the arrow. So oxygen, we have 2 oxygen on the left because we have this diatomic molecule of oxygen, and it's 2 oxygen per molecule. And on the right, only 1 oxygen. So the next step is to use coefficient to balance. And here, a magnesium is already balanced. So you will want to balance oxygen by making it 2 on the right side. So we will multiply on the right side by 2, and this coefficient will go in front of MgO, the formula of the product on the right side. So it looks like this. You will place the coefficient 2 in front of MgO on the right to balance the oxygen. Then you want to recount your elements. Magnesium, there's still 1 on the left. And now the 2 also applies to magnesium. The 2 applies to the whole formula MgO. So that means now we have 2 magnesium on the right. Oxygen, still 2 on the left. And on the right, we have two oxygens, because 2 times 1 oxygen per formula. So by recounting here, we saw that magnesium is not balanced now. And so we will need to balance magnesium now. Oxygen is balanced, so we don't touch oxygen. So to balance magnesium, you will need to make it 2 on the left, 2 magnesium on the left. For this, by placing a 2 in front of magnesium, because it's just magnesium here, it does not change the count of other elements. So it's easy, you just place a 2 in front of magnesium, and that will make it 2 magnesium on the left. And we still have 2 magnesium on the right. So this is balanced. Oxygen, we have 2 oxygen on the left and 2 oxygen on the right. So we check here that the final equation is balanced, and that's what we wanted. And remember that when equations are balanced, they satisfy the law of conservation of mass. It means that we have the same mass before the reaction and after the reaction. Mass has not been created or destroyed. So let's practice with this problem. When aluminum metal reacts with air, it produces a white powdery compound called aluminum oxide. So when you have something that reacts with air, it means it reacts with oxygen. Oxygen is the gas that will react with many things, that surrounds oxygen. So reacting with air, you want to read between the lines here that it means reacting with oxygen. So again, we will have plus oxygen gas in the reactant side. Aluminum metal, again, it's a metal. When you have a metal, it's made of just aluminum atoms. And so the formula will be the symbol of the metal, Al, and as a solid, right? Metals are solid, so you will have Al as a solid plus oxygen. Yeah, in words, this is aluminum plus oxygen gives aluminum oxide. So now we need to find the formula of aluminum oxide. And here, Al2O3, where this came from. So aluminum is a metal from group 3A. Remember that even though it's just touching the staircase line, it's not a metalloid, it's a metal. Think about aluminum foil in your kitchen. It looks like a metal. And it's a predictable ion. Ions, metals in group 1A, 2A, and 3A are predictable ions, and the group number is equal to the charge of those metals. And so aluminum is an aluminum 3+ ion. Oxygen, we saw earlier, is also a predictable ion in group 6A. 6 minus 8 is -2. Oxygen will be a -2 ion because it's a non-metal, it's negative. Here you would do the crisscross trick where the charge 2 from the oxygen will become a subscript for aluminum, and then the 3 from the 3+ of aluminum will become a subscript for oxygen. And so that's why the formula is Al2O3, because those subscripts cannot be simplified. You cannot simplify 2 and 3. So that's our skeletal equation here. Al solid plus oxygen gas gives Al2O3, which is a solid. It's again a white powdery compound. So we want to count the number of aluminums. On the left we have 1, on the right we have 2. Let's count oxygen. On the left we have 2, and on the right we have 3. So both are unbalanced. Let's start with aluminum. If we balance aluminum, we want to make it 2 aluminum on the left so that we have the same number on both sides. To make it 2 aluminum on the left, you want to place a coefficient of 2 in front of just aluminum here, and that will apply just to aluminum. So that balances aluminum. To balance oxygen, when you have 2 and 3, there's nothing that can, the only way to make this balance is by making it 6. You find the least common multiple of 2 and 3, and it's 6. So that means on the left side, we will have to multiply by 3 to make it 2 times 3, 6. And on the right side, we will have to multiply by 2. 3 times 2, 6. So on the left side, you will place the 3 in front of O2 because that's the molecule that has the oxygen. And so we will make a 3O2, and that will be 6 oxygen on the left. And for the right, the 2 will be placed in front of Al2O3, right? You cannot change the formula. It has to apply, the coefficient applies to the whole formula. So it goes in front of Al2O3. This way we have balanced oxygen and we have 6 on both sides. However, the 2, as I said, applies to the whole formula of Al2O3. So that means this changes the number of aluminum on the right. And now we have 2 times 2. You multiply the coefficient by the subscript. And so now we have 4 aluminum on the right and only 2 on the left. So it's not a problem. You can change the coefficient you placed earlier and remove it. Instead of multiplying by 2 on the left, we need to multiply by 4 so that we have 4 aluminums on the right. And so the 2 that is in front of aluminum now has to become a 4. So we have 4 aluminums plus 3 oxygens molecules gives 2 Al2O3. So let's check that it is balanced. Let's count the aluminums. We have 4 aluminums on the left and 2 times 2, 4 aluminums on the right. It's balanced. Oxygen, 3 times 2, 6 oxygen on the left, and 2 times 3, 6 oxygen on the right. So this is balanced. And so this equation is balanced now. Let's continue practicing with the combustion of ethyl alcohol, and the formula is C2H5OH in a flambe. A flambe is a brandied flaming dessert. So by the end of this chapter, you will get to know that combustion is burning. I will repeat that a lot, and I want you to start learning that combustion is burning. Whenever you're burning something, you're doing a combustion reaction, and combustion reactions need oxygen to happen. So that means you will have oxygen as a reactant on the left side. It's oxygen from the air, so it will be the gas. Combustion of compounds containing carbon and hydrogen always makes CO2 and H2O gases as products. CO2 is a carbon dioxide and H2O is water. So the skeletal equation then looks like this. You have the ethyl alcohol, C2H5OH. It's a liquid. It's an alcohol as a liquid. You will make it react with oxygen from the air. Typically, you need a spark or a flame to start this reaction. And it will burn and give carbon dioxide and water, the two common gases here. And that's very typical of combustion reactions, that you produce carbon dioxide and water if what you're burning is a compound made of carbon and hydrogen. So let's count the number of carbons on both sides of the equation. On the left, we have 2 carbons. On the right, we have 1 from CO2, right? Hydrogens, we have 5 hydrogens plus 1 in the ethyl alcohol. So that's 5 plus 1, 6 on the left, and 2 on the right from the H2O. Oxygen, we have 1 oxygen in the ethyl alcohol plus 2 oxygen in the oxygen molecule. So that's 3 on the left. And on the right, we have 2 oxygen from carbon dioxide plus 1 from water. So it's again 3, right? So looks like oxygen is balanced, carbon and hydrogen are not. And typically when you have these 3 atoms, carbon, hydrogen, oxygen, you always want to start with carbon and hydrogen and finish with oxygen. You will see that it will save you a lot of time and frustration if you do it this way. So let's start with carbon. And carbon, we have 2 on the left, 1 on the right. So let's make it 2 on the right by multiplying by 2 on the right. And that coefficient 2 will have to go in front of CO2 because that's the molecule that has the carbon. And by doing this, we make it 2 carbon on the right. That's balancing carbon for now. Let's balance hydrogen. We have 6 hydrogens on the left and 2 on the right. We can make it 6 on both sides by multiplying by 3 on the right side. That coefficient of 3 will have to go in front of water because that's the molecule that has the hydrogens. So we put 3 in front of H2O, and 3 times 2, it will make it 6 hydrogens. So that balances hydrogen for now. Oxygen, the count we have on the right side is not correct anymore because the 2 coefficients we just placed are changing the number of oxygen. So we need to count again the number of oxygen. And so we have 2 times 2 from the carbon dioxide, that's going to be 4, plus 3 times 1 from the water. So that's 7 in total. So now we have 7 oxygen on the right and still 3 oxygen on the left. So let's try to make it 7 on both sides. And so on the left, we have 1 oxygen in the ethyl alcohol and then the molecule of oxygen. Because the molecule of oxygen is just made of oxygen, if you change the coefficient in front of that molecule, it will only change the number of oxygen, and that will be convenient. So let's keep the 1 isolated, the 1 oxygen from the ethyl alcohol apart, and then that will make it, so from 7 you remove 1, it's 6. So let's make it 6 with the oxygen molecule that is O2. So that means instead of having 1 plus 2 here, let's make it 1 plus 3 times 2. Let's make it 6, where oxygen is by itself. This way, we will make it 6 plus 1, 7. So the 3 here, the coefficient 3 has to go in front of the molecule of oxygen, O2. And this way we have 3 times 2, 6, plus 1 from the ethyl alcohol, that's 7 on the left. So that looks like it's balanced. Let's make sure it is balanced by counting again everything. So carbon, we have 2 carbon on the left, 2 carbon on the right with the CO2. Hydrogen, we have 5 plus 1, 6 hydrogens on the left, and on the right, it's only in the water, and we have 3 times 2, 6 oxygen on the right. So that's balanced for hydrogen and carbon. Let's look at oxygen. Oxygen, we have 1 oxygen in the ethyl alcohol, plus 3 times 2, 6 from the oxygen. So that's 7 on the left. And on the right, we have 2 times 2 from the carbon dioxide, plus 3 times 1 from the water. And so it's 4 plus 3, and that's 7 as well. So our equation is balanced as it is.